In order to solve this by substitution, we need to solve one of our equations for one of our variables. And the best way to pick out the one to solve for is to look for one that has a coefficient of positive 1. And the only thing that fits that criteria is this x right here. So I'm going to take that equation, I'm going to rewrite it, and I want to solve it for x. So I'm going to add y to both sides, and I would get x equals, I'm going to write y plus 1. So now what I'm going to do is I'm going to take this y plus 1, and I'm going to put it into the top equation wherever I see an x. So I'm going to rewrite, instead of 8x, in parentheses, I'm going to write what I know x is equal to, and then I'm going to copy down the rest of the equation. So now I have an equation where I'm only using the letter y. So I'm going to distribute this 8. So I would have 8y plus 8 minus 7y equals 2. I can combine these two, they're like terms. 8y minus 7y is 1y, but I'm just going to write y. And I'm copying the rest down. And then I'm going to subtract 8 from both sides so that I can get y by itself. So I have y equals negative 6. That's half of my answer. Now I need to take this and plug it back in to get my other answer. There's a couple different ways you could do this. Probably the best way would just be to plug it back into either one of these two original equations. I would choose the bottom one because it's a little simpler. You could plug it back into this equation over here, but the problem is if you made a mistake, you might end up getting the wrong answer. So I guess it depends on what you prefer. I'm going to plug it back into the original. So I'm going to say x minus y, which is negative 6, equals 1. Negative 6 actually turns into positive 6. And then to solve, I would subtract 6 from both sides. So I would end up with x equals negative 5. So my final answer would be the ordered pair, negative 5, negative 6.